Welcome to the section Encrypting and SSH Hardening. In this section, we'll cover these topics: GNU Privacy Guard, GPG, encrypting partitions with Linux Unified Key Setup, LUKS, encrypting directories with eCryptFS, using VeraCrypt for the cross-platform sharing of encrypted containers, ensuring that SSH Protocol 1 is disabled, creating and managing keys for passwordless logins, disabling root user login, disabling username password logins, setting up a chroot environment for SFTP users. Now we move on to the first video of this section that deals with GNU Privacy Guard. In this video, we're going to focus on GPG for encrypting and signing. Getting started with GPG requires you to first generate your GPG keys. You'll do that with this command. The output of this command is too long to show all at once, so I'll show relevant sections of it and break down what it means. The first thing that this command does is to create a populated .gnu pg directory in your home directory. You'll then be asked to select which kinds of keys you want. We'll just go with the default RSA and RSA. So type 1. For decent encryption, you'll want to go with a key of at least 2048 bits, because anything smaller is now considered vulnerable. Since 2048 just happens to be the default, we'll go with it. Next, select how long you want for the keys to remain valid before they automatically expire. For our purposes, we'll go with the default key does not expire. So type in 0 and enter. Then it asks if key doesn't expire at all. Enter yes. Provide your personal information. We need to construct a user ID. Fill in all the details. Create a passphrase for your private key. The passphrase is created. This could take a while, even when you're doing all of the recommended things to create entropy. Be patient, it will eventually finish. By running a sudo yum upgrade in another window, I created enough entropy so that the process didn't take too long. Verify that the keys did get created using this shown command. And, while you're at it, take a look at the files that you created using this command. These files are your public and private keyrings, your own gpg.conf file, a random seed file, and a trusted users database. Let's encrypt a super secret file that we just can't allow to fall into the wrong hands. Enter the passphrase. Note that the -c option indicates that I chose to use symmetric encryption with a passphrase for the file. The passphrase that you enter will be for the file, not for your private key. One slight flaw with this is that GPG makes an encrypted copy of the file, but it also leaves the original unencrypted file intact. So list all the files. Let's get rid of that unencrypted file with shred. We'll use the -u option to delete the file, and the -z option to overwrite the deleted file with zeros. Enter the command for that. It doesn't look like anything happened because shred doesn't give you any output. But an ls-l will prove that the file is gone. See, it's shredded. Now, if I were to look at the encrypted file with less secret_squirrel_stuff.text.gpg, I would be able to see its contents after being asked to enter my private key passphrase. This is the file. As long as my private key remains loaded into my keyring, I'll be able to view my encrypted file again without having to re-enter the passphrase. Now, just to prove to you that the file really is encrypted, I'll create a shared directory and move the file there for others to access. I will create a directory shared. It's not possible as the directory already exists. Then enter an alternative command. Enter these commands one by one. When I go into that directory to view the file with less, I can still see its contents without having to re-enter my passphrase. But now, let's see what happens when Maggie tries to view the file. Move to User Maggie. Then move to Shared Directory. And when she hits the Y key to see it anyway, she can't see anything. Poor Maggie really wants to see my file, but all she can see is encrypted gibberish. What I've just demonstrated is another advantage of GPG. After entering your private key passphrase once, you can view any of your encrypted files without having to manually decrypt them, and without having to re-enter your passphrase. But let's now say that you no longer need to have this file encrypted, and you want to decrypt it in order to let other people see it. Just use GPG with the -D option. Move to Shared Directory and open the file. The warning message about the message not being integrity protected means that I had encrypted the file, but I never signed the file. Without a digital signature, someone could alter the file without me knowing about it, and I wouldn't be able to prove that I am the originator of the file. Now we will perform a hands-on lab, combining GPG and tar for encrypted backups. For this lab, you'll combine tar and GPG to create an encrypted backup on a simulated backup device. You can perform this lab on either one of your virtual machines. Start off by creating your GPG keys. You will do that with this command. Follow the procedure that was shown previously. Create some dummy files in your home directory so that you'll have something to back up. For that, enter this command. Create a backup directory at the root level of the file system. In real life, you would have the backup directory on a separate device, but for now, this works. Change ownership of the directory to your own account and set the permissions so that only you can access it. Create an encrypted backup file of your own home directory. Enter this command for that. Compression is optional, but we'll go ahead and use XZ for the best compression. Now, let's say that either your home directory got deleted, or that you accidentally deleted some important files from your own home directory. Extract and decrypt the original home directory within the backup directory. That's all about GNU Privacy Guard. In the next video, we will encrypt partitions with Linux Unified Key Setup.